Example 12. A sharp-edged orifice 75 mm in diameter lies in a horizontal plane, the water jet being directed upward. If the jet rises to a height of 8.08 meters and the coefficient of velocity is 0.98, determine the head under which the orifice is discharging, neglecting a resistance. The discharge CF coefficient of contraction is 0.65 and the power lost in watts. So for the head under which the orifice is discharging, remember that the jet rises to this height and this is equal to the actual velocity head in the jet. So 8.08 equals actual velocity head. So from there we can solve for the actual velocity. Then we equate it to C sub V square root of 2G times head. Then we can compute for the head. So 8.08 equals V square over 2G or actual velocity head. So V is square root of 19.62 times 8.08, so 12.59 meters per second. Then 12.59 equals C sub V 0.98 square root of 2G times head. So 12.59 square over 0.98 square equals 19.62 times the head. So the head is equal to 8.412 meters. Then the discharge kaotog, where C is C sub C, C sub V. Then pi diameter, pi radius square, pi 0.0375 square. Then square root of 19.62 times head. So Q equals kaotog. So Q equals C sub C 0.65 times 0.98 C sub V times pi 0.0375 square root of 19.62 times 8.412. So the discharge is 0.03615 cubic meters per second. The power lost in watts, power lost is Q times specific weight of water jet, times the head lost. Where the head lost is head times quantity 1 minus C sub V square, so 8.412, quantity 1 minus 0.98 square. The head loss is 0.3331 meter. Substitute above, power loss is 0.03615, specific weight of water 9,810 newtons per cubic meter, then head loss 0.3331 meter. So that the result is in watts. So power lost in watts is 118.1 watts.